Hey guys, this is AS Physics Homogeneity using SI base units. What is homogeneity? Homogeneity is to prove that the left hand side of the equation equals the right hand side of the equation. Let's take distance for example. I know that the SI base unit for distance is meters, right? And what homogeneity says is that whatever unit is present on the left hand side, in this case meters, should also be present on the right hand side. So the product of speed times time should give me meters. Now I know that the SI base unit for speed is ms negative 1, right? And for time it's seconds, or s with a positive 1. Now this positive 1, negative 1 cancels out and I'm left with meters. So this proves that whatever is present on the left hand side is also present on the right hand side. All types of energy and work done has the same SI base unit. We know that work done has the SI base unit of kg m2 s negative 2. And whatever energy is present, be it kinetic or gravitational, will always have kg m2 s negative 2 as their SI base unit. When a unit is squared, whatever the quantity contains will also get squared. Let's take velocity for example. We know that velocity has the SI base unit of ms negative 1. Now what this power says that ms negative 1 is squared. When something is squared, whatever the unit is present inside that bracket will also be squared. For example, let's take meters first. When meters is squared, this m will get a 2, and when this s is squared, it already has a negative 1, so this negative 1 gets multiplied by the 2 and this becomes ms negative 2. Let's take acceleration for example. We know that acceleration has the SI base unit of ms negative 2. Now this squared means that whatever is present inside that bracket will also be squared. So this m gets a square and this s also gets a squared, but it already has a negative 2 power. So when this negative 2 multiplies with this positive 2, it becomes negative 4. When dealing with homogeneity, we will ignore any constants or numbers. Let's take kinetic energy for example. We know that the formula for kinetic energy is half times mv square, and this half is a number, it's a value, so it's going to be ignored when we are solving this. Similarly, pi has a value to it. It is a constant because pi has the value of 3.14. So we're also going to ignore pi's when we're solving any homogeneity questions. Now let's do this kinetic energy question. I know that kinetic energy or work done has the SI base unit of kg m2 s negative 2, and whatever is present on the left hand side must also be present on the right hand side. So kg m2 s negative 2 should also be present here. So when I'm solving this, I should get kg m2 s negative 2, right? So I know that mass is kg, m represents mass, v represents velocity. So v is ms negative 1. And this is squared, as I said. When this gets squared, whatever is present inside the bracket also gets squared. So I get kg m2 s negative 1 times 2 gives me negative 2. And this tells me that whatever is present here will always be present on the right hand side. Let's solve this question. The energy E stored in an electrical component is given by E equals Q squared over 2C, where Q is charge and C is a constant. Use this equation and the information in A to determine the SI base unit of C. They've said that c is a constant, but they never said that c is a constant with no units. So we can't ignore c because c has some unit to it. It has a unit that we need to find. But I'm going to ignore this too because it's a number. Any number will be ignored when we're solving homogeneity questions. So first of all, I'm going to make c the subject of the formula because I am told that we need to find the SI base unit of c. So instead of writing e, I'm going to replace e with c to make c the subject of formula, and instead of c, I'm going to write e. Let's break this down further. I know that q is charge, and what's the SI base unit of charge? Q has the formula of CS, or current times time. And I know that current has the SI base unit of amperes, or A, and seconds has the SI base unit of S. So Q has the SI base unit of AS. Instead of writing Q, I'm going to write AS. But it is squared. That means everything that's present inside Q will be squared as well. So A gets a square and S gets a square over energy. Now energy, as I said, has the same SI base unit of work done. So work done has the formula or SI base unit of kg m2 s negative 2. I can't leave this here. I need to simplify further. So I'm going to move this entire denominator up, and when I do this, each power that's present on each unit will change to negative. So I get a square, s square, and kg, instead of being positive 1 becoming negative 1, m2 instead of being m positive 2 becoming m negative 2, and s negative 2 will become s positive 2. And since I have two similar units, right, s and s can add up. This is positive, a square and s positive 2. So this s positive 2 and this s positive 2 gets added up, and it becomes s4, right? Plus 2 plus 2 gives me plus 4. So s4. I get my final answer as square s positive 4 kg negative 1 m negative 2. And since I don't have any two similar units, I'm going to leave this as it is, and that's going to be my final SI base unit of C. Let's solve this question. The frequency f of a vibration of mass m supported by a spring with spring constant k is given by the equation F equals Cm P Q K with the power of Q, where C is a constant with no units. What are the values of P and Q? When they say C is a constant with no units, we are going to ignore this because it's a constant that has no units. So there is no unit of C, so it's useless to us. So we're not going to consider C when we're solving this question. Homogeneity says that whatever unit is present here must also be present here. So whatever the base unit F has will also be the base unit that this entire thing will have. What is the SI base unit of frequency? I know that frequency is velocity over lambda. And what is velocity? Velocity is ms negative 1. And what is the SI base unit of lambda? Lambda is the measure of distance. So lambda will have the SI base unit of meter. So I'm going to replace lambda with m positive 1. Now this m positive 1, when it goes up, it becomes m negative 1. This m negative 1 and this m positive 1 cancels each other out, and I'm left with s negative 1. So the frequency has the SI base unit of S negative 1. So whatever is present here will be present here. So the product of this should give me S negative 1. M represents mass, and we know that mass has the SI base unit of kg. And K represents spring constant. Spring constant has the formula of force over extension. And force is, as we know, kg ms negative 2 over what's extension. We know that extension is the measure of length or distance. So extension will have the SI base unit of distance, which is meters, with the positive 1. When this m with the positive 1 goes up, it becomes m negative 1. So kg ms negative 2 and m negative 1. This m positive 1 and m negative 1 cancels each other out, and I'm left with kg s negative 2. So the spring constant will have the SI base unit of kg s negative 2. And this has a power of q, while kg has a power of p. Homogeneity says that I must have s negative 1 present on the right hand side, and there is no kg present on the left hand side, right? So that means on the right hand side there must be no kg present as well, but I do have 2 kgs present, and that means I somehow must have to cancel these 2 kgs out, and that can't be done when p and q have similar values given to it. Let's take neg a as an example. I'll replace p by negative 1 by 2, and I'll replace q by negative 1 by 2. When this negative 1 by 2 gets a power, it's going to be negative 1 by 2, and this s gets multiplied by negative 1 by 2. So negative 2 times negative 1 by 2 gives me positive 1. So instead of s negative 2, it becomes s positive 1. And this does not cancel each other out. That means A cannot be the answer, so A is wrong. Let's solve for B. Let's replace P with negative 1 by 2. And let's replace Q with 1 by 2. When I replace Q by 1 by 2, the entire of the SI base unit will get this power. Kg 1 by 2, and S negative, instead of being negative 2, it's getting multiplied by 1 by 2. So negative 2 times 1 by 2 gives me negative 1. Now I have kg negative 1 by 2 and kg 1 by 2. This does cancel each other out because negative 1 by 2 plus 1 by 2 gives me 0. And I'm left with s negative 1. So these two are similar, therefore B is the correct answer.